should like to tell you that I have seen some of the experiments shown in this film actually carried out at the All-Russian Physiological Congress. As you can imagine, technique is everything. Besides such work as you are about to see, Ryukhonenko shares the credit for the methods of human blood transfusion which were first developed in the Soviet Union and are now practiced in this country, which has saved so many lives during the war. What enabled Soviet scientists to solve this problem? Long ago, science established the fact that animal organs and tissues isolated from the whole organism can be maintained in a living state. But in order to achieve this, special artificial conditions must be created. Isolated organs can be brought to life even though they've been removed from the animal's corpse some time after death. Here's a dog's heart. It can function as well in artificial conditions as in a living organism, and for this purpose, blood is introduced into the cardiac vessels. The isolated heart beats just as it did a few hours previously in the living dog. The following experiment is conducted on lungs taken from an animal. Bellows distend the lungs and fill them with air. The venous blood is forced into the lungs by the action of the pump. The dark venous blood passes through this tube. In the lungs, it takes up oxygen and becomes arterial blood. The isolated lungs breathe, producing the same chemical changes as in the living animal. An animal's head can also live in the isolated condition. Here is the plan of the experiment. The arterial pump takes arterial blood from the reservoir to the head, while the venous pump drains off the venous blood. The blood is arterialized in the reservoir, where there is a steady flow of oxygen. The artificial blood circulation ensures the metabolism necessary for the life of the head. The isolated head lives on for hours and reacts to external stimuli. The isolated head even reacts to light and to sound. The revival of individual organs enabled scientists to proceed to experiment on reviving the whole organism. The revival of the whole organism can be achieved with the help of an apparatus called the autojector. The autojector carries out the functions of the heart and lungs. As we know, the heart, by its rhythmical contractions, supplies the body with arterial blood rich in oxygen. After losing its oxygen, the blood returns to the heart through the veins. From them, it flows into the lungs, whence with a fresh supply of oxygen it returns to the heart, and thence flows into the arteries of the organism. The autojector works on the same principle. The apparatus includes a system of pumps for supplying blood and drawing it off. The arterial pump supplies the organism with arterial blood. When the blood has given up its oxygen, the venous pump draws it back into the reservoir. Here, just as in the lungs, it's enriched with oxygen and returns into the organism. The blood passing into the arteries of the body ensures the necessary metabolism. In this way, the autojector can perform the work of both the heart and lungs. We begin the experiment of revival. The experiment is carried out on a dog. A substance which prevents clotting is introduced into the animal's blood. The dog is under an anesthetic. It doesn't feel pain. No interruption of the animal's normal functions has yet occurred. The dog reacts to touch. Its pupils are normal. A special apparatus, the kymograph, registers the breathing and the function of the dog's heart. The pulse and breathing are normal. The experiment begins. All the blood is drained off through the carotid artery. heart has stopped. This is one of the animal's last gasps. This is the final breath. The dog is dead. Without operative interference, death would be final, as the disintegration of the body cells would gradually set in. The autojector is being attached before starting the revival. The arterial pump is connected with the artery. The venous pump is connected with the vein. Ten minutes have elapsed since the animal died. The blood removed from the animal is pumped back into its vessels by the autojector. The autojector ensures a normal blood circulation in the organism, replacing the action of the dead heart and lungs. The artificial blood circulation gradually induces the heart to start beating again. The heart's action begins to be normal. The first sign. The respiration is gradually restored. The dog breathes more normally and evenly. The animal's condition approaches normal. We can now disconnect the autojector and leave the organism of the dog to maintain life with its own resources. The dog soon shakes off the effects of the anesthetic. The dog is still weak and can't move. After 10 to 12 days, the dog returns to its normal state. After the experiment, dogs live for years, they grow, they put on weight, and have families. For a number of years now, 3 dogs have been under observation in the Voronezh Medical Institute after being revived by artificial blood circulation. This dog, Bunny, was revived in 1939 after having been dead for 8 minutes. Black Ears is the offspring of revived parents. She herself was revived in 1939 after 11 and a half minutes of death. Naida was revived in 1938 after 15 minutes of death. These experiments on the revival of dogs have shown that the process has no harmful effects on the animal organism. The question of the revival of animals is one of the most interesting problems in physiology today. Experiments on revival have added to the valuable store of our knowledge of experimental medicine.